Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with count data and discrete modeling. In the last lecture we have highlighted this particular concept with lots of what we can call as lots of difference corresponding to different types of data, that to putting or bringing count data and differentiating how count data can be different from other types of data. So, it is a kind of specialized kind of data through which we can analyze some of the engineering problems. As a result, we have a modeling structure or a different kind of clusters, engineering econometrics clusters, that is what called as count data and discrete modeling. So, in the last lecture we have already highlighted this count data, what is exactly count data and how you can understand and how you can do the modeling with respect to count data. Once again I am bringing the structure. Count data is a kind of data where information should be positive in nature and it should be integer type only. That is the only two requirements which is actually for the count data. It is slightly means it is exclusively different from binary data and the kind of ordinary data. So, now corresponding to count data. So, the discrete data is a type of data that can be grouped into classification, right. It is generally based on some kind of counts only a finite number of values is possible and the values cannot be subdivided meaningfully. Like there are two things, if the data is not actually positive in character and not in a kind of an integer type, then it cannot actually represent the facts as per the particular requirement, means in the case of count data modeling. Again, so another constraint to this modeling is that you cannot so easily actually divide the samples into different subsamples. So, that means so subclustering is not so easy here. So, that means technically now there are three things you have to be very careful. First thing, the values of the variable should be positive in character, then it should be exclusively in numbers, that means integer type, and again these informations or this data cannot be subdivided into another group, because it will not give you some kind of meaningful representation kind of presentation. Like we have already discussed, half death or half suicide, these are all not the actually clear cut kind of information so far as count data is concerned. So, similarly, you cannot just divide this group data into different kind of clustering, that is what called as subdivision. If it is the data that cannot be broken down into a smaller unit and will not add any value or it will not bring any kind of meaningful kind of interpretation. It is typically in a situation where we count information like whole numbers only. There is no such thing as half defect or half death or something like that. In brief, the particular subdivision does not really add any further value addition again, that too so far as description is concerned. Now, I will bring some of the classic examples relating to count data and discrete data, and very common in social science environment or engineering science environment, number of children, number of marriages, number of arrests, number of traffic accidents, number of floods, number of deaths. So, these are all common examples where the information exclusively count data type. integers and positive in character, simply integers and positive in character, right. So, that means non-negativity and the information should be in numbers only. So, no fractional information, it is exclusively integer type. So, count data have typical features, that is integers and cannot be negative. Sometimes it may be positively skewed, but in reality we have no issue whether it is a positively skewed or something exclusively normalized. So, we have no issue, but ultimately we should specifically follow that whether the structure is actually non-negativity in character and integer type. So far as modeling is concerned corresponding to the count data. So, we have a couple of models, that is starting with the logistic regression, then Poisson regression. So, we have lots of kind of variety altogether, but in fact the logit model to the count data is not so good. Of course, if the particular counting or the particular informations by default will be in a 0 1 structure, then we have no issue. It may be coming under the count data, but that may not be the actually generalized case, that is very exceptional case. So, because ultimately we like to understand here variables and the corresponding information to the variable which we call as data. So, we have two restrictions here. So, the information should be positive in character and integer information should be in numbers only, that too in integers only. So, if it is actually 0 1, then 0 1 itself is an integer. Okay. So, that means if the information will be only in 0 1, so that can be also called as count data type, but the reverse is not true. That means you cannot just generalize that 0 1 means it is actually the entire integer type. So, it is the special case of integers type, that is called sometimes in the optimization problem we call as 0 1 integer programming. So, here actually also within the integers, if it is a 0 1 kind of information only, the particular problem is different, and we can use various types of model including the logit models. Okay. But if the information is not 0 1 only, then you cannot exclusively use this kind of binary model, binary choice model, logit model, or the kind of probit model. So, what is happening here? So, we can still use something like that. Before that starting, these are all actually different kind of examples again, where we can actually use to understand the count data and the kind of modeling. Okay. So, I will bring these examples after highlighting some of the count data models. So, so far as a classification is concerned, that too with respect to count data, that means regression modeling with the count data or model fitting with count data. So, it is actually very straightforward clustering. So, first one is the logistic regression type, where you can use, but provided it should be actually some kind of informatic, that to integer types and positive one. Then the second model connecting to this count data is the Poisson regression modeling. Third one is the negative binomial regression. We have also models like 0 inflated count models, and under this we have two different forms, 0 inflated Poisson distribution and 0 inflated negative binomial distribution. Then 0 truncated counted models. So, here again we have actually with respect to Poisson distribution again and the negative binomial distribution. Then we have two other models and random effects count models. So, that means technically these are the complete model structure so far as count data is concerned. So, now two things are very important. First thing, the data which we like to use in these models are exclusively count data type, that is the values of the variable means values of the variable means it is a kind of information that what data is positive in character and should be integer in nature. Now, we can see how we can actually use these models. So far as a regression kind of structure is concerned and the kind of particular engineering requirement is concerned. So, starting with simple logistic regression, this is what the means here every times means whatever models we are going to discuss all has actually specific density functions, right. So, that means logistic has its density functions, probability density functions, then Poisson probability density functions, negative binomial density functions. So, that means technically we have a particular functional form and we can just connect to that particular function form and then go for the estimation as usual flow. Of course, you have to check the balance if it is actually a nonlinear in character, then you may have to think about whether to use OLS technique or maximum likelihood estimate technique. If it is linear kind of structure, for instance let us say binary choice model simply, then you can go for simple OLS kind of estimation. But if you say starting with a Poisson distribution and binomial negative binomial distribution, so in this kind of modeling, so it is in nonlinear in character and maximum likelihood estimation can be deployed there. But ultimately what is more important in this kind of modeling framework, that to count data modeling, that in other words regression modeling with count data, so is the density functions, because we strictly use you can say for 5 different kind of modeling structure, starting with simple logistic regression to Poisson distribution to the negative binomial distribution and so on. So, every times you like to check how is the density function and what kind of data and how is the problem flow and how to start the process. It is as usual simple regression modeling or simple time series modeling or penalty modeling, but ultimately it is the means here it is the move is actually with respect to the data and the kind of connecting point is the density functions. So, if the data is positive in character and integer type, then you like to check the flow. Once you go through the problems, you can understand whether it is the Poisson type distributions or it is the negative binomial distribution type, and accordingly you can bring that density function and then connect with this modeling, and finally you can analyze the problem as per the particular requirement. So, ultimately two things very important. So, the type of data, and that too you have to think whether this particular data structure, of course it is with respect to positive in information and non-negativity and then integer type, then again you think actually what distribution exactly it follows. So, whether it is a Poisson type, then you use starting with Poisson regression modeling. If it is actually normal following with binomial distribution, then you can start with negative binomial regression modeling. So, like that is what the actually a checkpoint and the kind of turning point. The rest of the process is as usual actually similar. So, now starting with the logistic function, this is how the estimation, and here actually the problem is actually the kind of estimation. Of course, if you find out the odd ratio, and after getting the odd ratio means technically if you start with actually p values here, then the requirement of the p values is that it should be within 0 to 1, but ultimately if you start with count data modeling, that too in a kind of means logistic model with the count data framework, then the odd ratio should be actually integer type, okay, integer type, and then the kind of structure through which you can go for the estimations. But in a reality most of the count data models means most of the instances the particular framework will follow Poisson distribution type and the kind of binomial distribution type, and then we may have some situation where there is a clear cut integration between binomial distribution, means Poisson distribution, and binomial negative binomial distributions. So, this is how the structure of the logistic functions looks like, the graphical look. And let us start with the Poisson distribution. This is one of the heart of the count data modeling. So, what I have already mentioned. So, this kind of modeling, most important is the density functions, with means which kind of models you like to finally use depending upon the type of data and the kind of natures, that to non-negativity and the integer type. And so, obviously, one of the such kind of modeling is the follow of Poisson distributions, and the density function that too for the Poisson distribution is like this. So, it is actually exponential type of things, a to the power minus lambda, lambda to the power k by k factorials. That is what the exact actually flow. So, what is happening here? It is on how this actually the density function is all about, right. Like we have already discussed logistic functions and normal distribution functions for probit model. So, it is also similar kind of structure, it is not highly different. So, here RT is the expected number of events, that to this one, and K is the number of discrete events, that is what the count data. And then we have here actually let us bring here that kind of concept. That means here technically, so this is one of the parameters which is very important in the Poisson distribution, minus RT, sometimes we call as lambda, and then this k component. Okay. So, RT that is the lambda is the expected number of events, that is calculated with the help of R and T, that is the rate with respect to time, and K is the number of discrete events, that is what the count data is all about. Now, so that means how the mean operates with a number of counts or the kind of discrete events. So, Poisson distribution has only one parameter, that is the RT, that is the lambda, which is both the mean and the variance. That means technically it is a kind of special kind of distributions where mean and variance are coincide. So, however, often we find the variance is larger than sometimes it may be larger or it may be lesser with with mean actually. In that case, Poisson distribution have some kind of issue. So, that means okay. So, the technically two things are very clear here. Before you start applying this kind of modeling, so your first thing data should be very specialized, that to count data types where information should be positive and integer, and again while doing this one. So, it is the kind of parameters that to lambda, and we like to check what is the game between mean and variance of this parameter. If the mean and variance of these parameters are actually coincide, then the particular choice means we have to make a choice about the Poisson Poisson regression modeling. If mean and variance are not equal, then you can go for negative binomial distribution. That is what the turning point about the choice of these two models. So, far as in the first instance the count data modeling is concerned. So, now what is happening here, you have to go to this structure, then so what is exactly situation here which I have already highlighted. So, lambda is the kind of Poisson distribution parameter, and we like to find out mean of this parameter and variance of this parameter, and we like to check whether this mean of this parameter and variance of these parameters are coincide or not. That is the first checkpoint you have to do. Of course, the first checkpoint is the data structure, then second checkpoint is the mean and variance of the parameter, and then it will take you to the clue whether to move towards the Poisson regression modeling or negative binomial distribution modeling. So, now you will find mean variance of this parameter will not even the same, then by different you will differentiate and you have to choose a particular technique as per the requirement. So, now moving towards this, I will just give you the simple examples how what are the situation of the Poisson distribution. So, you see here. So, the graph will be actually in nonlinear in character, a slightly somehow exponential type, because the model if you look to these models here, it is starting with exponential type. So, obviously, if you plot, then the structure will become like this, and that itself will see whether you are in a position to use Poisson distribution or not. So, that means like as usual regression modeling, we like to choose a particular functions. What we supposed to do actually, we go for graphical check, which can give you some kind of indication about the exact functional forms, whether to fit with linear structure and or nonlinear structure, or even if in the nonlinear structure what type of functional form you have to bring. So, so here in the counter task modeling, we can also follow the similar kind of structure in just check how is the behavior, and then you can actually go for the particular choice of the modeling, and then you can go for the estimation. And the second model related to the counter data modeling is the negative binomial distribution modeling, and it is just extensions of Poisson distribution. And here we allow the parameter to be a, instead of lambda, here we call as gamma, and that is one of the parameter for negative binomial distributions. And here the issue is actually with respect to two things, r and k corresponding to the lambda, which are r and t, small r and t. So, rate with time. So, here also r is the expected number of observation, that is called as discrete or continuous, and k is the over dispersion. That is very actually a big issue in the kind of negative binomial distribution. So, that means technically, so it is not a uniform kind of variations. We call it dispersion means if the variance are not actually equal over the time or something like that. So, if it is not equal or not constant or not stable, then by default we will come to follow the binomial distribution modeling rather than Poisson distribution modeling. So, the gamma function actually follows the the kind of structure like this, and then we will actually go for the kind of estimations. So, again in order to understand actually the concept negative binomial distribution. So, here the mean of the negative binomial distribution is r, and the variance of the negative binomial distribution is r plus r square by k. So, which is actually the differentiating point between the Poisson distribution and binomial distribution. In the case of Poisson distribution, the mean distribution will coincide, that is actually called as lambda, but here the gamma parameter that to the mean variance are not actually same. So, it is actually corresponding to this functional form which we have already highlighted here, r and k, and that too with this particular exponential type function. So, we have the mean called as r, and then the variance of this particular distribution is called as r plus r square by k. And since the mean and variance are not same, but of course, the distribution density function is different, but by the way when we calculate mean and variance, that is the expected value means expected value of these happenings and the variance of this particular happening. So, if they will not coincide, then by default we declare that it is the pattern of binomial distribution, otherwise it is the kind of flow of Poisson distribution. The negative binomial distribution can converts to the Poisson distribution if k stands to infinite. So that's the kind of the structure, like we have discussed the concept called as central limit theorem, where if you start increase a sample size, that means when n stands to infinity, every distribution will converge to normal distribution. So in this case also it is a similar kind of flow. When k will start moving or approaching towards infinite, so then this negative binomial distribution will converge to the Poisson distribution. So that means technically, so if your data set is very huge and huge, so ultimately, so the difference between the two model will not so much significant. So but ultimately there is no harm if you will start with building regression modeling with Poisson density function and negative binomial density function. Ultimately we have no actually clear idea where where the n will be approaching the infinite. That means technically you can increase sample size subsequently, then ultimately at a particular point of time they will actually converge. But if that is not the case, that means if the sample size is lesser to that particular situation, then by default the model can be with particular choice only. Either you can use Poisson distribution or you can use actually negative binomial distribution. So both cannot go simultaneously, because in the case of Poisson regression modeling, one of the indication that the mean of the parameter and variance of the parameter should be same, but in this case, so the mean of the parameter and variance of the parameter are different. That is what is called as over dispersions. And in the case of in the situation where n approaching infinite, then there is high chance that they can converge. That means technically we start with the assumption that mean and variance are not equal, and as a result you can start with using normal negative binomial distribution, that to negative binomial regression, and then when starting start increasing sample size, and then ultimately you will find the deviation or the difference between mean and variance over the time will be minimize and then coincide. So in that case, so the particular distribution will converge to Poisson distribution, and then finally you can actually use Poisson regression modeling. That is actually kind of a simulated process, or you can call as one kind of sensitivity structure in the regression modeling. But ultimately if that is not the case, then we have two different models altogether. So one kind of model is the Poisson regression, and another kind of is a negative binomial distribution. And the kind of function, if you graphically plot, the behavior will be look like this, and by default it will give you the signal that you will go for negative binomial regression. So now considering the case which we call as the kind of binomial structure, the catch point is that what is the kind of occurrence point, or the kind of durations and the kind of rate of capture. That is how the big deal between the mean and variance. For this particular problems we apply the Poisson models and the negative binomial models, but ultimately that means technically both models will be very close to each other, like we have the closeness between logit model and probit model, because there itself also when sample size is substantially very high and high, then the difference of the estimated outcome or output will not actually so much, whether to use actually logit model or probit model. The same thing also here. So when your sample size is substantially very high, then the outcome between Poisson regression modeling and binomial regression modeling will not actually so high. So that's actually big deal. That means it clearly gives the signal that when your actually the information is having a high, then ultimately you have lots of flexibility. So that times actually either you can use say Poisson regressions or binomial negative binomial regression, like we use actually logit or probit. So, we have no issue, but when your sample size is very small one, even if it is follows with count data pattern, still you have to make a choice. If it is a very less sample, then by default you cannot use both the models simultaneously, but if the sample size is substantially very high, then you can use both the models simultaneously. That's how the big deal or big understanding. So, this is how the kind of a little bit differentiating point between Poisson distribution negative. So, the yellow mark is following the Poisson distribution, and the kind of blue one is actually showing giving indication about the negative binomial distribution. Okay. So, likewise there are different kind of flow here, and that is how the kind of means it is exclusively which you can call as over dispersions, which implies that variance of the data is greater than that expected under the distribution. That means technically it is the mean actually. So, if the variance is somehow greater than to mean, then that declaration is the over dispersions, and that too the situation where we can use actually a negative binomial regressions. And if the data are over dispersed, that means but that is ignored, you are means this is kind of underestimating the their uncertainty. So, that means technically before you start the process about this kind of count data modeling, so we have 2-3 checkpoints. So, the first checkpoint is the kind of information that to data which you would like to check that whether it is actually a exactly count data type, where we have where the checkpoint is again and the negative non-negative values and then the integer type values, and it will be more interesting, the result will be more interesting and the model will be more interesting if it is not exactly the 0 1, it may be above than 0 1, and that is how the count data starts bringing actually the a kind of reality. And then the second checkpoint is actually the parameters value, which is the differentiating point between the two different models, that to Poisson regression modeling and then the negative binomial distribution modeling. So, where one case mean variance will be equals, and then the clear cut choice will be the Poisson regression modeling. If the mean and variance are not equal, then the situation will be called as over dispersions, and in that case the particular choice will be the negative binomial regression modeling. So, that is how the difference, and so far as a count data model is concerned, so you can actually one way you can use the Poisson regression modeling, the other way you can use the negative binomial regression modeling. So, the choice ultimately depends upon the type of data and the parameters actually reaction that to with respect to mean and variance. And in the next lectures we will discuss some of the problems, that means we bring some kind of live problems that to application where we can use this Poisson regression modeling and the kind of binomial regression, negative binomial regression modeling. With this we will stop here. Thank you very much. Have a nice day.